The starting point of our application is a user interface without any visualization, inspired by the simple search interfaces. We have just one search field for searching various bibliographic entries like author's name or titles. We have a login button and icons of various visualizations that are available in this application. The order and size of these icons changes during the interaction with the visualization for recommending the best fitting visualization. Let us start with a search. I'm getting, based on my query, 3 visualizations that is showing different aspects of the information found in the BibTeX entries. This tree-map similar visualization highlights author because this term was mostly found in authors, and provides a navigation through the different, for example, categories. On the other hand, we have the disambiguation of the name Fellner, the different writings, a temporal view of the published articles, and at the same time there are changes on the order and size of the recommended visualizations, whereas the first 3 visualization was chosen to be visualized on the screen. Now let us navigate through the categories, and I see that there are more articles found in computing methodologies, in computer graphics, and methodologies and techniques, and I see different articles related to this subtopic, computer graphics. I can choose one article, for example, sketching subvision surfaces, and see the related BibTeX information in an HTML view. I can check a look further for more articles. With the brushing and linking metaphor, I'm able to check a look on several articles and get information in this area. Let us take a look on the other example that is mentioned in the paper. We get another view on the user interface of our application. We see that there are more authors again found in articles, but the term GPU visualization was found in articles, so articles are highlighted. But I'm interested in the authors, so I'm taking a look at the authors, and I see that there are various authors who has publications in this with the term GPU visualization, and one author more than other. If I click on his author, I'm getting a full view of all his articles. That means that we have a kind of querying on demand. I am now able to put or dismiss visualizations on the screen. And the system is registering my interaction for analyzing my behavior and choosing the right visualization in the mentioned canonic user model. Let us search for something else, for the term semantic visualization. Now I get another view, and I see that there are only 2 articles, for example this one and this one. I can choose one of these articles, and I see in one view who are the authors of this article and who are and in which categories this article is published. The order and size and the choosage of the visualization and the recommendation of the visualization are based on the canonic user model that we have designed. If I want to have an individual view, I can log in as a user and I see what is my preferences on the data. I'm navigating mostly to the categories. I'm more interested in computing methodology and computer graphics. And so this is an article that is more useful for me than other articles mentioned here. If I log out, the canonic user model is again used for visualizing the information and adapting the visual presentation of this information. If I search again for the same term, I'm getting the same information as before. Now I'm checking the look on this paper, on the authors of this paper, and I see that one author is of interest for me, and I want to have all his publications. The system decides during this interaction that the visualization should be changed and chooses a similar visualization to show me the author in connection with his co-authors. One last example. I want to search for useful semantic visualizations, and I see just one paper with the information and the related graph information shown on this screen. Thank you very much for your attention.